Today's lesson is on abstract fractional equations, which we've worked on, and we've eliminated the denominator by multiplying by the reciprocal. So I want to go back and look at one of the problems, and in particular I'd like to look at problem number 15 from lesson 39, and that's on page 180. Alright, so that problem says ax squared minus 4 over a over x squared over a plus 6. Alright, and in this lesson, because we have no equal sign, we're going to find a common denominator, right? So we're going to find a common denominator for both the numerator and the denominator. So looking at our numerator, the only denominator we have is a. So we're going to make that our common denominator. And we do that by multiplying the first time by a over a. And we end up with a squared, x squared over a minus 4 over a. And then our denominator, the only denominator we have, is an a. So we're going to make 6 have a denominator of a, and we do that by multiplying by a over a. Because by our rule, it says the only way we do not change the value of this is by multiplying by the effect of 1. So we have x squared over a plus multiply our 6 times our a over our a. So now I can write this entire numerator over a. I have a squared x squared minus 4 over a. All that is over x squared plus 6a over a. Now at this point, really I can just say my denominators are eliminated. But effectively what I'm doing is multiplying by the reciprocal of this denominator and eliminating the a's. So the reciprocal is a over x squared plus 6a, a over x squared plus 6a. My a's eliminate this way. Also, my a's eliminate this way. Only because I'm multiplying, those eliminate. And I end up with, let me erase this part. This is my numerator, a squared x squared minus 4 over x squared plus 6a. And this is my answer. Okay? Now in lesson 40, what we are doing is we're now going to solve for one of the variables. All right, so you need to be able to manipulate your equations to be able to eliminate. In lesson 40, we have abstract equations, but we have an equal sign. And anytime we have the equal sign, we're going to eliminate all denominators. So, looking at example 40.1, we're going to solve for x. This is on page 181. And we have a over x plus m over a equals c. Now to eliminate our denominators, we have to multiply every term by the least common multiple. And the least common multiple is all your denominators at this point. It's xa, xa, xa. Many of you forget you also have to multiply on the other side of the equal sign. Otherwise, you change the value of the equation. See, I'm just multiplying by some number, but I have to multiply by every term to maintain equality. All right? This is really just over 1. My x's eliminate, and I end up with a squared plus my a's eliminate, xm equals cx. Alright, so the first step was to eliminate the denominators. Now, because I'm solving for x, the next step is to move every term with x to one side of the equal sign. So I want, this one has no x, I'm going to leave it here. I'm going to move this one to the other side, okay? And I do that by subtracting xm. All right, so I'm isolating the one I'm solving for all to one side of the equation. So of the equal sign, I have a squared equals cxa minus xm. All right, now both of these terms have x in it, so I can factor out the x. So that's the third step. First, you eliminate denominators. Second, you isolate that variable on one side of the equal sign. Now you factor it out. So if I factor out my x, x times CA gives me CXA minus x times M gives me XM. Now I've got x isolated. It's multiplied by something. I can move this term to the other side through division only because it is multiplied. CA minus M, CA minus M. These cancel out, and I have x equals a squared over CA minus M. All right, let's work 40.2. All right. 40.2, we're solving for M, okay? And the equation is x over M plus C equals y over A. I have an equal sign. I'm going to eliminate my denominators by multiplying by the least common multiple. It's MA. Multiply every term by MA. And before I multiply, I can reduce. Because I'm multiplying, I can reduce my m's. So a times x is ax. For this one, there's no denominator. So this is MAC equals, here I can eliminate my a's, and it's YM. So first eliminate denominators. Second, isolate the term, the variable you're solving for on one side of the equation. That has no m in it. This one does, so I'll move it to this side. I do that by subtracting. And the result is AX equals YM minus MAC. Now I can factor out my M, and the result is M times Y minus AC. Now I can divide by Y minus AC on both sides to get M by itself. And so the result is M is AX over Y minus AC. Now there was one other type of problem that people had trouble with on the test, and I would like to work one. It's number 12 on page 180. All right. And this is the problem. X cubed plus 6x squared plus 5x over x squared plus 2x minus 15 divided by 7x plus 8x squared plus x cubed over x squared plus 5x minus 14. All right. First thing you should know is we never divide fractions. We multiply by the reciprocals. But because I have polynomials, I can factor these. Okay? So let's look at this numerator. I can factor out x and have x squared plus 6x plus 5 over, and I can go ahead and factor the denominator. My first term is x. Then I look at factors of 15 such that when they're multiplied together, I get negative 15. Add them, I get positive 2. So, and that is plus 5 minus 3. I'm going to go ahead and flip this by to multiply. I do the reciprocal. X squared plus 5x minus 14 over, and I'm going to write this in descending exponent order. X cubed plus 8x squared plus 7x. And I'm going to factor this side now. So this is, I can keep my numerators, x times, let's factor this one. X squared plus 6x plus 5. My first terms are x plus 5 plus 1. It's just multiplication, so I can go ahead and factor this and just write it next to that because you're just multiplying. My first term for x squared plus 5x minus 14 is x. Now, to get 14 by multiplying is 7 and 2. But I must get positive 5, so it's plus 7 minus 2. Now I look at my denominator. I have x plus 5 times x minus 3. Now here I'm going to factor out an x. Alright? And I end up with x squared plus 8x plus 7. But I can factor this. And this factored is x plus 7 and x plus 1. Okay, and replacing that in my denominator. Now I look at my terms and see what I can eliminate. Because they're multiplied, I can now eliminate like terms. I have an x that can be eliminated, and I start at my numerator. I work from my left to my right. Do I have x plus 5 in the denominator? Yes. Do I have an x plus 1? Yes. Do I have an x plus 7? I do. Do I have an x minus 2? No. So here are the two terms that I have left. My answer is x minus 2 over x minus 3. All right? And that is it for this lesson.